Okay, let's talk about some more cell phone DC electronics. The reason that it's DC is because it's direct current. Current only travels one way. Um, so this is part six, series and parallel circuits. So essentially, for most DC electronics, you have series and parallel circuits, and they work in tandem with each other. You'll have parallel circuits that are essentially nodes within your overall design. So in a cell phone board, you'll have something like a chip. Uh, we'll say something like an audio IC. Connected to that audio IC could be either series or parallel components. And the reason that this is important is because when some components are in series, you could have a failed component. That component in series would mean that you most likely have an open somewhere. Without that component, the exchange of electrons cannot happen. You have the open bridge at this point. For parallel components, each component operates separately. And for a parallel component, even though one of the components may have failed, it could still pass a current. It could still receive voltage. And in that sense, you still have an operating device or an operating circuit. However, it might not operate the way you want it to. Another thing in a parallel circuit is that you could have a failed component and that component is failed and it's pulling electricity away from or power away from other components. And in that sense, removing that failed component can restore functionality for a phone. So, breaking this down a little bit, the component labels and everything themselves don't mean as much as the understanding of the relationship between the components in the two circuits. So for the circuit on the left that has the V2, R4, R3, the two resistors are in series. This is a series circuit. And the reason that it's a series circuit is because the components are connected end to end from one pole to the other. That's what makes this a series circuit. And so in a series circuit, you'll have a voltage drop across each component. Each component does its job to mitigate the pressure in the circuit, to slow down the pressure. And for this one, because both of the resistors are each 100 ohms, they're doing equal work. If you were to remove one of the resistors, for resistors, they fail as an open. They burn up, and then essentially they're no longer connected between their 2 points. And when that happens, you have an open, and so you no longer have a working circuit. You'd have to replace the resistor in order for that circuit to work again. So in a series circuit, you can have other components that can fail short, and you can have components that fail open. When you have that, you can have two components in series, and if it fails short, essentially it's pulling those electrons straight to ground. And this means that you are probably putting too much stress on the other component as well, because now it's pulling the full voltage when the other component in the series should be doing some of the work. Now, the circuit on the right is parallel circuit. And if you look, you can see actually two components. One's a R2, which is a little squiggly line that usually means a resistor. And then next to it, which is kind of cut off, but you can kind of see what it is it looks like an ice cream sandwich. It's a capacitor. And these two components are in parallel. They share a common ground, but they're each doing separate work. When the resistor passes, they both share a common voltage too. There's a current drop across parallel components. For a series circuit, there's a voltage drop. Each component consumes voltage. For a parallel circuit, each component consumes current. And so if you could figure out what the current is of R2 and what the current is of that capacitor, then you would add those together, and that's the current of the circuit. For the series circuit, the current is the same, the voltage is different. And so how does the parallel circuit apply in cell phone electronics repair? So if you have the same voltage, if you're looking at a cell phone and you're looking for voltage and you see it, and it seems normal, but you're getting a weird current draw, or you're getting a weird current reading, then you most likely have a failed component in parallel. And the other really important thing about this is that, and I will make a quick diagram for this, is that a lot of times, a lot of components are attached to ground as a means of just filtering the signal, making the signal cleaner, because there's a lot of noise in the transmission of electrons from one pole to the other. And when you put components in parallel, that voltage keeps passing through, but it makes the voltage become more tame, and it makes the current become more tame and understandable. Okay, so the circuit has changed a little bit. Now we have a circuit with 3 capacitors in parallel. Now here's the thing. If there's 2 things that can happen with these capacitors. It can fail, which they'll fail short. A capacitor needs a supply of either current or voltage in order to complete the circuit. It needs a certain supply of voltage or current to complete that circuit. And if it doesn't happen, or if it doesn't have it, then it's an open. And what happens is when they fail short. So they're constantly in a state of being closed, which they're usually not. And there's 2 things that can happen. They can fail, or they can get knocked off, which they're an open. For situation 1, where they fail, if they're connected to ground, then that voltage and that current goes to ground, because electricity follows the path of least resistance. And this often is what happens in a cell phone circuit on a cell phone board, is that you'll have a capacitor that's been worked over, it's been over voltaged or water damaged, and it gives up, it dies, and it shorts itself out. Now it's pulling all the energy into the ground plane. And so that line is no longer communicating, it's no longer traveling and doing its task. It's been routed into ground. And that's what happens when a capacitor shorts. When it fails, it shorts to ground, if it's connected to the ground plane. Now here's the other thing, is a capacitor can get knocked off, which means that it's been removed from the circuit. That would be considered an open. Now, capacitors in this circuit are probably redundant, which means that not all three of them are needed. They're only there to help purify, distill that signal so it's nice and clear. And if you're to think about it, it's kind of like if you have a radio signal. If you're trying to get your favorite radio channel and you turn the dial and it's kind of fuzzy, you turn the dial the other way and it's kind of fuzzy, and you turn the dial right into that one spot where you can hear it clearly, that is kind of like putting all these capacitors in parallel. It's not quite the same, and that might be a little misleading, but essentially what's happening is that the capacitors make it so that the signal is to that point, the signal being the flow of electrons. It gets it to that point where it's very stiff and rigid and understandable. Because a lot of times what happens in for cell phones or computers, is that it's transmitting a small amount of voltage to another component as a means of communication. So one component will say yes, and a yes means 1. Otherwise, it's a no, and a no means 0. Well, so that other component can understand in very clear terms, it needs a really, really crisp signal. And so these capacitors in parallel to ground basically clean up that signal. So what if you lose one? Well, the signal's still there. It might be a little bit more muddy, but it's still there. And so if all three of these capacitors were in series, where they were connected end to end to end, all the way to its destination, and one of them failed short, most likely what would happen is the other two would fail as well. Because the amount of work they now have to do in series would be too much, and they would also essentially probably fail. So putting them in parallel consumes some of the current, but keeps the voltage. And a lot of times that's what you'll need for communication.